Yeah. Good morning, all of you. Welcome to the live session for 10th class students. Physical science topic is acids, bases, and salts. So, in this live session, I'll discuss with you about especially strength of the acids or strength of the bases. So, how to find out the strength of the acids or the bases topic will be discussed in this live session. So in the last class, I have discussed about activity number 9, that is about what happens when we mix acid into the water or water into the acid. That topic clearly discussed. It is an exothermic process, right? So here, simply to avoid any injuries or effects by acid mixing in the water or mixing of water in the acid will be overcome. Simply the technique we are following always, acid must be added to the water slowly with a constant stirring. With constant stirring. So that we learned in the previous activity number 10. Let us move to the another activity here. It is about simply activity 10 to decide strength of the acid or maybe strength of the base. To decide the strength of the acid or the strength of the base. So here, for this you required a few materials. For this you required few materials. What are the materials we are using here? What are the materials we are using here? So simply that materials are here hydrochloric acid, an acid, and a base, right? So here I'm going to use two acids and two bases. Two acids and two bases. One of the acid is hydrochloric acid and the other is acetic acid. With that, I'm using one more, that is here base, sodium hydroxide. Also, we will collect one more base. It is simply sodium with the sodium hydroxide, ammonium hydroxide. One more acid we are collecting, ammonium hydroxide. Next, here you required electrodes, because here actually you are trying to find out the strength of the acid. You are trying to find out the strength of the acid here. That acid is strong or weak will be decided by the presence of number of ions in them. So number of ions produced by the acid or the base in the aqueous solutions, water, will be give you the strength of the acid or the base. So for that, you are depending on the acid or the ions that is diluting into the water. Okay, then we are unable to see the ions directly in the water. So what we are doing there, simply we are depending on the bulb intensity. So for that you are arranging one circuit. So you need electrodes. Next, here you need bulb connecting wires. Okay. Along with that, also you need distilled water and source of current. Okay. So here simply I got it, every material. Along with that, I am collecting a dropper, isolize water here. Why? Dilution purpose. We learned in the activity 8, ions produced by an acid or the base only in the presence of water. So that's why you need distilled water. Why distilled water, sir? Distilled water do not produce or do not have any ions in it. So that is the reason. Okay. Then after collecting all the materials, we'll go for the procedure and also observations. So here what is the procedure we are following here? Simple. For that, I am collecting one beaker. After taking a fresh beaker, add a few distilled water, fill, right, by placing electrodes in it. So I'm placing electrodes here. Then connecting the electrodes with the wires. So here, one of the electrode is connected to the AC plug and another electrode is connecting to the bulb terminal, right? So here AC plug is connected and bulb is connected. After that, you are connecting with the help of a key, this AC plug second terminal and bulb second terminal through a key. Then connected. Okay. Next, adding water, right? So what these, actually these are electrodes. Now observe them. Are that electrode directly in a connection or contact? No, they are not connected directly. So how to connect them? With the help of a liquid, distilled water. Now distilled water is filled. Then add acid, right? So here you are preparing simply HCl solution. You are preparing simply HCl solution here. So add it. Then next, just switch on that. With the distilled water, we know the bulb doesn't glow. Then after adding HCl solution, again switch on that. What happens? Observe. So now I'm switch on. Here observe. Then here you have to focus especially on the brightness of the bulb, right? Just keep your view or focus on the brightness of the bulb. Okay, then next, continue the same process, taking one more beaker or using the same beaker, but clean it well. Make it dry. Make it dry. Then what to do? What to do? Here simply the same process we can follow, adding or placing electrodes into the beaker, then complete the connection process in a proper order or maintaining the sequence of connection, right? Then they are connected here. They are connected here. Next, connecting the AC plug with the bulb terminal. Connected. Next, add liquid solution, that is here NaOH solution. What we are now taken into the beaker is that we filled the beaker with NaOH solution. Previously HCl solution, now NaOH solution. Then observe by switch on. Then bulb glows or not. Just you have to focus on it. So here what we are added, sorry, I mentioned as a NaOH solution, it is as acetic acid, right? So first here you have taken HCl solution and the next solution is acetic acid. So now just look at here brightness of the bulb in these two cases. Here you are observing more brightness here with this acetic acid in that beaker. The bulb will give you somewhat less intensity, more brightness, and acetic acid given you less brightness. So based on the brightness of the bulb, you are going to conclude that what we can conclude. So here I observed HCl giving you more intensity. HCl giving you more intensity. Then acetic acid given you less intensity. So from this, I am able to observe, or my observations made here simply the bulb glows brightly in HCl solution, and that intensity of the bulb brightness is observed less in acetic acid, lower. So more brightness, less brightness. So that I made Why? So that we will observe here. The reason behind the brightness of the bulb decreased in acetic acid, why it is with more brightness in the HCl solution. Let's see with sodium hydroxide and ammonium hydroxide. Following the same process, taking a beaker, then placing the electrodes, completing the connections in the sequence. Then here simply that electrodes come in contact with the help of a liquid solution. That liquid solution filled in the first beaker is sodium hydroxide solution. Then switch on, right? Supply the power. Then what happens? That liquid conduct electricity. Then the current passes through electrodes to the bulb. Then the bulb starts glowing. Then focus on the brightness of the bulb. Focus on the brightness of the bulb here. Next, same thing. Same thing. But here, change. What the filling basic solution is different now. Here, now I'm going to fill in this second beaker is with ammonium hydroxide. So that electrodes come in contact with the liquid solution is now acetic acid. Sorry, ammonium hydroxide. Basic now. So first we have taken NaOH solution into the first beaker. The next, that beaker is replaced now with ammonium hydroxide. Now switch on the key. What happened? Bulb blown. But the difference in them, what the difference is observed here? More brightness and less brightness. So that is the difference. So what are the conclusions or observations you are going to notice here? So your observations with the HCl solution and acetic acid. Now, brightly in a NaOH solution and the intensity of bulb is lowered, decreased in a ammonium hydroxide solution. So we have differences. Brightness of the bulb changed in different solutions. Brightness of the bulb is different in different solutions. So that we observed here. So with that, we are able to say now the reason behind it, number of ions produced in the solution. So here brightness of the bulb simply depending on number of ions produced in the solution. Number of ions produced in the solution. So with the number of ions produced in the solution, simply lower the brightness or increase the brightness of the bulb. So more number of ions, more intensity will be observed with the bulb. Less number of ions will be observed with less intensity or less brightness. So here simply more ions produced or present in HCl solution, and that CH3COOH is giving you less number of ions. So simply we have observed the bulb is blown in any solution, HCl, CH3COOH, NaOH and NH4OH, all are respectively, they are produced ions. So due to that, bulb blown, but that which produce more ions is decided as here stronger. Right? So here we know HCl is an acidic solution, CH3COOH acidic solution, and remaining two, NaOH and NH4OH are basic solutions. So from them, we are deciding now, depending on the brightness of the bulb, we conclude that that produce more brightness because of more number of ions. So simply that is said to be strong. That is said to be strong. So which are strong here? That is acid is HCl and the base is NaOH, because here brightness is given by them more. So cause or reason behind it, simply number of ions. Okay, the next, weak acid and the base. So weak acid is acetic acid and the weak base is NH4OH. So finally result is what? The result is intensity of the bulb depends on the number of ions produced by the solution, aqueous solution of acid or the base. So this is the conclusion we draw from the activity 10. So very simple. It is very similar to activity number 7. So while you are preparing, read activity 7 and 10 together. Because here in the activity 7, just you are observing bulb glown or not. Here, in this case, you are giving importance to the brightness only. Nothing is different. Same. Only you are giving importance to the brightness of the bulb. In the activity 10, in the activity 7, you are giving only importance to the bulb glown or not. No importance to the brightness of the bulb. So that's why I am advising you to read activity 7 and activity 10. Then observe them differently. Your observations are different in the both activities. So this is activity number 10. Then let us move to the next topic is about now pH scale. Next topic is pH scale. So here what is actually pH scale first? Right? So here simply this pH scale is also called as pH indicator or universal indicator, introduced by Sorensen. So here simply that pH scale help us to find out acidic nature, basic nature or neutral nature of the given substance. Any nature. 3 will found. So what is the difference? Already we have pH solution to find the acidic nature, basic nature and neutral in nature. Why do you prefer or why we need one more indicator, sir? So here this pH indicator will help you to find strength of the given substance, what's acidic or basic or maybe neutral. So its strength also we can find out. So simply Sorensen introduced this pH scale in 1909 with the terms pH or pOH. pH or pOH. So already you know what is H, what is OH, ions. So here you are able to know the strength of the acids by finding the number of ions present in the acidic medium and in the basic medium. They are given by a number, right? They are given by a number using a word called potential. That pH is given taking a letter P, stands for potential in German language. It is taken from the German language. P stands for potential. What is the meaning of potential here? Potential means power. Potential means power, or also it stands for the meaning concentration. Right? So how much or what number of ions situated in the given substance in liquid solution, that we are able to notice with this pH. Then simply you are assigning a value that is given as strength, right? So strength of hydrogen ion or strength of hydrogen potential, right? So it gives you hydrogen ions concentration, right? Hydrogen ions concentration. So here applications are there. This pH scale useful in our day-to-day life to find importance of that pH value in our stomach. Sometimes you may feel uneasy, uncomfortable, dizziness, right? that is due to indigestion. So why? Here, biologically, we can call it a gastric juice that will be released in our stomach. Okay, so that pH is important in our stomach. Maintain. If that pH slightly changes, what happens? Problems, acidity, ulcer, right? So that is important. Also, that importance of pH in our daily life is, it is water treatment. We use also in water treatment, purification, cleaning, right? Next, here we are also having importance of that pH in our day-to-day life, in our mouth, in the body, in our mouth. So daily morning you are brushing. What the reason? Simply rinse with the water. What happens? That we will learn. Then pH of land. Also we have importance of the pH in our soil. We are giving importance to the pH, right? In manufacturing or preparing medicines. Also we are giving importance to find the nature of solutions with this pH only. So use of pH scale to find out the nature of the substance in different fields, right? So this is importance of pH. Then here, let us see that. What is pH scale actually? Let's see the pH scale. Here, the pH scale consists values. It consists values. Actually, that strength is expressed in terms of values that are given here 0 to 14. 0 to 14 values we are giving. So here that values also we are able to classify into three categories. What they are here? Neutral substances, acidic substances, for basic substances. Let's see that values, how they are assigned on the pH scale. So each value consists different color. Each value consists different color actually. Look at them, that colors here on the screen. Very clearly, I am showing you that colors given by the pH scale, 0 to 14 values. So here you are indicated with a value 0. That is specially for the red color. Changes in the color will be given with the different values here 0 to 14. So pH scale consists of values from 0 to 14. 0 to 14. So here, if it is specially indicating you, the color is 7. Color is green, dark green, right? So that is simply indicating the substances as neutral. So simply neutral substances pH value is equal to 7. Equal to 7. That pH value of the neutral substances, suppose lowered, less than 7, its nature changes towards neutral. 0 to 7 or less than 7, the range of pH is said to be for acids. It is indicating acidic substance. If the pH value of a substance greater than 7, right? So here 7 to 14, 7 to 14, that is specially for the bases. So here simply the values are assigned for the acidic substances 0 to 7, neutral substances, especially it is 7, equal to 7. If the value assigned more than 7, up to 14, 7 to 14, it is for neutral, basic substances. So acidic, neutral, bases. 0 to 7, acids. 7, neutral. 7 and above, 14. 7 to 14, it is for bases. So like this we are assigning. Then when you find the nature of the substance, I used a special word here for bases, alkaline, that which dissolves in water. So now look at, I am giving you one image with the pH values. Here sulfuric acid, battery acid, hydrochloric acid, they are less than 2. Less than 2. Lemon juice, orange juice, acidic rain, banana, right? So these are the important substances what we use in our day-to-day life, right? In different sectors we are using or we are dealing these type of substances, maybe in cleaning, maybe in purification, maybe in our food. We have everywhere importance to the pH. So what happens if the pH changes in your body, in your surroundings? That gives its effect. That gives its effect. So let us see here pH, paper color, and its color in different mediums. So here simply that pH scale and its color. Actually, that pH color or paper color is yellow. pH paper is a paper using or dyed with applying colors with the different chemical substances. Number of substances are used in making pH paper. That is finally obtained in a yellow color. Look at that. Then it is assigned with the values 0 to 14. So here 1, 2, 3, 4, 5. So up to 14. They are assigned with the different colors here. So simply, if you dip that pH paper in different substances, that changes into different colors. So each color assigned with a special value here to indicate the nature of the substance, as well as a value assigned for the color is to give the strength of the substance. Suppose if you got or given with a color 7 value or obtained green color, that is simply you have to notice the value of or the strength of the given substance is 7. So what is the nature? Neutral. Or you observed red in color, simply that we can decide the nature of the substance as acidic. So pH paper gives dark red color for strong acids. Red orange, right, changes depending on the strength of the given solution. So dark red, strong acid. Dark red for strong acid. Look at that. If you dip the yellow color paper, that pH indicator paper, into the acidic solution, it changes into dark red. That is for strong acid. Then in the neutral, it gives you green color. Yellow paper dipped into the neutral solution, then it changes into green color. So what we have to understand? Look at that. Indicators are given. So it is green, 7. The strength of the given substance is 7 and the nature is neutral. Then dip that yellow paper, pH paper, universal indicator, into basic substances. It changes into dark purple, that means violet color, or black. So that is simply here basis. Sometimes you may get dark blue also. Okay, so according to our textbook, dark purple, right? Dark purple, violet color, or it is giving you black color. So this is about a pH scale and its colors. pH scale and its colors. Here now, next topic is finding a pH values of different substances in our day-to-day life. Okay, activity 11 it is given as activity 11. So there is a table given in your textbook, and also they have suggested you to use different types of solutions which we come across in our daily life. Here I am classifying that table into different columns. One is serial number, then next substances or the solution what we are taken as sample here. Next, finding the color of the pH paper, identifying the color of the pH paper. The next here, assigning the value, pH value, then deciding its nature, either acidic, basic, or maybe it is neutral. So how do you decide? Based on the color of the pH paper. So here, serial number 1 to 17, I suggested in your textbook the same substances I am giving you here. So the first solution is here, HCl solution is given. So what to do? Take some certain amount of HCl solution into the watch glass or into the test tube. Or simple, take few drops of HCl using the dropper and add onto the pH paper. Then observe the pH paper color. Right? So pH paper color, here it is dark red. So what the value you can assign? Dark red. What the value is given on the pH indicator? They will give you one card along with the pH paper. So that card you have to refer with this color and assign the value. So here its value lie between 1 to 2. It is depending on the concentration, dilution, right? So if you are preparing strong, almost it is equal to 1.1, right? So nature is acidic. Then the next one we are taking here is acetic acid. So that acetic acid sample we can take into the watch glass or with the help of a dropper. So what the color here? Orange, red or orange. So for that, what the value is assigned on the pH indicator is 3. Then its nature is acidic. pH value less than 7. It is acidic. Next, ammonium chloride. It gives you green color. It gives you light green color, but not dark. Green only, but light green. So what the value for this given there? It is in between 6 to 7. It is in between 6 to 7. So lower than 7. Mild acidic, little acidic in nature. Mild acid. The next substance here, sodium acetate. It also gives you light green, but changes. So you have to observe 3. Green, dark green. Left side and right side also it gives you green color, but yellowish green, bluish green, like that we have differences. So according to that, you are assigning the value. It is equal to or just somewhat above to the 7. So its value is mild basic. Nature indicating you mild basic. Then next here the substance is sodium bicarbonate, NaHCO3, and its color will be observed here blue with the litmus paper. Then the value we are assigning for this is 8.3. Then the nature is basic. Next solution is sodium carbonate. Washing soda. Then its color is blue and the value is 10.5, basic in nature. Next one is sodium hydroxide. It is giving you purple color. Its value is, it is about 10.5. Almost it is 13 to 14. There is a mistake. It is 13 to 14. Strong base. This is strong base here. Then next substance is here distilled water, pure water. Take distilled water, sterilized water. Its color is green and the value is 7. Nature is neutral. After distilled water, we will take a lemon juice. So almost you will get near to the red, but its value is not 1, 2.2. Near to red, not exactly dark red. Right? Its value is 2.2. Sir, you are given 2.2. Always it is fixed, sir. No, it changes depending on the sample you are collected. Lemon from different areas will be with a different taste, sour, less or more. Right? Some are tasty, heavy, very sour. So its acidic nature maybe increases. Sometimes you may observe that value is 4 also sometimes. Right? So don't fix to these values. Right? I am giving only one sample. I am giving the range lie between. It is 2.2 to 4 also sometimes. So acidic in nature. Next substance is carrot juice. It gives you light green. It is 5 to 6 range, and mild acidic. Next, coffee, acidic only. It is also giving you somewhat light green. 5 pH value is 5, almost 6 to 6.5 also sometimes. Mild acidic. Next one is tomato juice. Also gives you parrot green. 4 value is 4 acidic. Tap water, somewhat nature has adopted. It is towards neutral only, but pH value is somewhat more. Next, banana juice. Banana juice, yellow, orange. It is acidic. Sometimes you may feel the taste of the banana is sour. Next, aerated water, soda, right? Soda water, yellowish green, pH value lie between 6 to 7, mild acidic. Then next, saliva, before meals and after meals. Its nature changes. So before meals, it gives you somewhat green, but its pH value lie above 7. Mild, basic in nature. Mild, basic in nature before meals. It mixes with the food. Then after taking meals, it changes towards acidic. pH value lowered, mild, acidic. So these are the values. Activity 11 according to your textbook, right? So just I'm giving you the range of pH values, not exactly these values. You may not get that exact values. It changes depending on the sample type, right? Then next we'll go for applications of pH in our day-to-day life. So is there importance of that pH in our day life, everyday life, day-to-day life? Are you dealing with these acids and bases in your daily life? Yes, sir. So here we are dealing with the different substances in our day-to-day life, as your food, or maybe in different sectors, in medicines, or in the crop fields, cultivation, or in a house, domestic purposes, cleaning, right? So in different ways we are using them. So here our plants and animals are sensitive towards this pH. As definitely how they are. See here, plant affected by the water only, just changing its strength, weak, maybe die. That aquatic animals, aquatic plants, depending on the water only, right? Also soil effects. So lives, death, causes death. pH range only, narrow change in the pH value affect the aquatic life. The next pH change causes tooth decay. See that image. So change, yellowish color or black color, or damages the gums. So it is effect of a pH change in your mouth. Next, here pH in our digestive system, stomach, also important. So here in intestine. So before that, here in your stomach, that food reaches and combine with the gastric juices. What the nature of that? So that is also affecting. So in our digestive system, we have importance. Then pH of the soil, we have importance with the soil also. Why, sir? How, sir? It is giving life to the plants, for example. Seed growths, tiny plants, then big trees also. They are sensitive towards this pH. So healthy growth of soil for the plants, healthy growth of plants, you need pH of the soil actually neutral. It is highly impossible, because all the wastages we are releasing through the water into soil. So how it can be? But We have range. What range? The next, self-defense by the animals or the plants. Honeybee, for example. So all these in our day-to-day life, we are observing, we are dealing with them. So we have importance of that pH in our regular life, day-to-day life. So what they are? Let's see individually. So our plants and animals are sensitive to this pH range. Yes, they are sensitive. Narrow pH range change, small value, right? So they are sensitive to the pH value. Why, sir? How, sir? Because here, especially now, I am discussing about acidic rain here. Aquatic animals and plants, they are depending on natural water, that is from the rain. So rainwater supplied to the plants. Rainwater is supplied to that plants. So what happens with that? Aquatic plants and animals, simply they are depending on the rainwater. So here, if that rainwater changes towards acidic or basic, automatically that can be affect the life of aquatic plants and animals. So they have a lower pH value, maximum 5.6. If the pH value lower than 5.6, less than the 5.6, what happens? So here, that life of aquatic animals or the plants will be in danger. pH of rainwater, if it is lower than 5.6, that aquatic life will be in danger. So they are sensitive in the range of pH. Simply, it is 5.6 to 7.5 or maximum 8 only. But more than that, less than 5.6 will be in danger. So what is actually changes the rainwater nature? See that clear image. Acidic rain. How that acidic rain causes here? Simply due to the pollution that released from different sectors here. Maybe it is from the industries, right? Maybe from vehicles or domesticated substances, what we use for cleaning purpose, right? All these polluting the water, that water goes, or maybe we are releasing that pollutants as gases combined with the acidic water and gives as acidic rain. When we call the rain as acidic rain, if the pH value lower than 5.6, it is called as acidic rain. So that can affect the life of plants or animals simply, right? So here simply, if acidic rain occurred in your surroundings, what happens? That will be released simply into the streams, rivers, lakes, ponds. Then what happens? Acidic rain causes the pH value of that water lowered simply. Its acidic strength decreases the pH of the water available in that source. So automatically what happens? That can affect the aquatic life. So biodiversity of water body will be reduced. It causes death. So it is important in our regular life. See that. Also it changes the quality of air. We have importance that acidic rain simply causes risk to the human. Maybe they faces the problem asthma, breathing, respiratory diseases. Also, maximum number of times if you receive that acidic rain causes cancer. If you drink that water, maybe affects your brain also. So these are the effects of that acidic rain in our body, on our body. So it is that what? Acidic rain affecting aquatic life as well as terrestrial. On us, human beings also affected with this. breathing problems, cancer, brain affected, maybe asthma problem. So these are the effect on our body, human being, right? The next, here importance of the pH in our daily life, especially on tooth in our mouth. Are there importance to the pH in our mouth? Yes, we have. Already in the activity 11, I have given you the value of pH of your saliva before meals and after meals. So before meals, the pH of saliva is towards basic. After meals, it changes towards acidic. So if the pH value of your saliva mouth lower than 5.5, directly it can affect your teeth. How, sir? Why? Because there is a reaction, as you learned in the lab activity, acid reaction with the metal. So what metal we have in mouth? Simply calcium, teeth, enamel, right? So that has calcium. So that calcium react with the acid present in your mouth, released as saliva. So that saliva changes towards acidic. Why? After meals. Because the food particles remains in the gap of teeth. That fermentation process takes place. It releases acids. It's a acid nature changes, base changes towards acid. So that is simply prevented by using toothpaste, right? So here that process of damaging your teeth by the reaction of acid and the mineral is called tooth decay. So that simply prevented by using toothpaste here, right? Why toothpaste? Because the toothpaste has its nature mild basic. It is mild basic. So neutralization reaction, as you learned in the activity 5, acid treated with the base treated with the acid, neutralizing, strength decreased, right? So here that strength of the acid decreased in your mouth using bases. Regularly rinse your mouth with water. Okay, so new nature of the saliva before meals, basic. Nature of that saliva after meals, acidic. Its values changes, right? So that's why rinse your mouth or clean your mouth, brushing twice in a day, morning and before sleeping, night, compulsory. In the duration, morning to night, rinse your mouth with water several times, after meals especially. Okay, and this is importance of pH in your mouth. So look at the figures given here to understand about them. Tooth decay. So this type of effect you see in your teeth gaps is simply symptoms of tooth decay. Here gums also damaged. Sometimes it may turns into black color, corrodes the teeth, right? So here it is about tooth decay. So regular brushing, rinsing mouth, teeth will prevent that effect, right? So this is about importance of a pH in your everyday life, especially in your mouth. The next importance in our regular life is in our digestive system. So are there acids present in your stomach? Yes, sir. Gastric juices we can call as. So we have importance of that gastric juices, major functions in our digestive system, intestine. So sterilization of the food, protein digestion, activating the pepsin, activating the intrinsic factors, stimulating the delivery of bile and enzymes, closing the epsocial sphincters. Sorry, that terminology is different, biology. Then opening the pyloric sphincters. So these are the major importance we are having towards that gastric juices in our stomach. Then that food goes directly into this stomach. Then it will be combined with that gastric juice, then digest with that enzymes. So here, simply the composition, what released in your stomach is actually HCl called as gastric juice, hydrochloric acid released in your stomach. It's water quantity. How much is produced in a day? It is almost 2 to 2.5 liters per day is produced. Its pH value range is 1 to 2. So is it strong or weak? Actually, it is strong. It is what? Strong in its strength. So strong acid is released in your stomach. So here what happens if there is no food at that time? If there is no food in your stomach at that time, so actually it is released in your stomach time to time. It depends on your habit of food, right? Habit of eating food. So at that time, if there is no food in your stomach, what happens? That causes effect directly on the walls of stomach. So burning sensation, acid reflux, right? Some liquid juice comes out into your mouth from the stomach, acid reflux, right? So that causes immediately. So eat the food in regular time intervals, maximum just 15-20 minutes or half an hour maximum. If not taking that food in regular time intervals, automatically it gives its effect on the stomach. So how to control it? Consuming antacids. What is an antacid here? Antacid is a substance which has its nature basic. So here, acid in your stomach, you are swallowing, taking as basic. So what happens? Acid base reaction will give you neutral substance. So neutralization reaction takes place. So that eno, rantac, gintac, histac, diazine syrup, gelusil, antacid syrup, gasofast, all these are what? Antacids. To get relief, to prevent acid effect on your stomach, right? So that's why we are using them. That is neutralization reaction with antacids. The next, that pH importance in the soil. So here soil also has importance of this pH. Actually, you need neutral soil for the healthy growth of plant, but it is impossible because always we are polluting, maybe with the water or maybe with the other substances throwing into the soil, decomposition. So soil nature always changes, but here we have a range for healthy growth of plant. It is 5.5 to 7.5. In that range, plants grow healthy. So here finding the soil pH value using pH paper. So it is giving green color here. So what the range of the pH of the soil here? 7. So it is okay. Very healthy soil it is actually. But it is impossible due to the pollution of soil. So it changes acidic nature or towards basic nature, right? So the range is given 5.5 to 7.5. If it is lower or more than 7.5, 5.5 less or 7.5 above, then it affects the growth of the plant. Simply, we have the range. See here, it is above 8.3. The soil nature is alkaline, right? Here, it affects the growth of plant. It is lower than 7 or equal to 7.5. Iron availability becomes a problem in the soil. Efficiency of minerals. right? Next, it is 6 to 7.5. 6 to 7.5. Okay, here, near neutral, acceptable for the most of the plants for their growth. It is reduced less than 5.5, right? What happens? There are microbes decreases in the soil. Lower than 4.6, too acidic. So that affect the growth of plant and also affect the products from the plants. So this is the importance of a pH of soil in our day-to-day life. The next here, importance of that acids with the animals and the plants. Suppose here honeybees, ants, or a dog plant that affects on your skin, burning sensation, swelling, reddish, right? So all these due to what? The chemical substance released by the honeybees or sting of wasp. Honeybees or sting of wasp that can release a sting, something as what inserted into your body, that can release a chemical on your body that give you burning sensation and pain, swelling. Look at that, where it sting, that gives you with that bite, swelling, burning sensation. So how do you get relief? Using basic substances, because that can release acid, formic acid. What they can release? Formic acid. That formic acid gives you this effect. So to get relief, just you have to treat with basic, mild basic substances, maybe toothpaste, baking soda, or a detergent soap. With them, you can clean it, that area. Then you will get somewhat relief. Or take medicines, ointments to get relief from them. So with them, you will get a relief. After this, we have that topic is about salts that I will discuss with you in our next live class. So I will announce when we have the live class before the class only. So thank you for joining in the live session. And also you can give your valuable comments about my